Hey, what's up, guys? This is Chung here. So today's daily challenge problem, number 752. Open the lock. So you have a lock, and with 4 circular wheels, right? So each wheel has 10 slots from number 0 to 9, and the wheels can rotate freely and wrap around. So which means that if you're like at number 9 here, you can either rotate forward or backward. So if you rotate forward, 9 will become to 0, right? And then you can always rotate backward, which will be 9 going back to 8, right? And each move consists of turning one wheel, one slot, right? So one slot means that you can only turn it once, right? I mean, basically turn it to its neighbors. For example, from 3, you can turn into 4 or 2, right? Again, from 0, you can turn it to 1 or 9. Same thing for 9, right? So the lock starts at this 4 zeros, and you're also given like a list of dead ends. So dead ends means that if the lock is at this state, right, you cannot turn that lock anymore. Okay. So then you're given like a target representing the values you want to unlock the lock, and return the minimum total number of turns required to open the lock, right? Or -1 if it is not possible. So yeah, for example, this one we have a few dead ends that which means we cannot uh, we cannot we cannot use then target 0202. So in this case, we need 6 movements, right? So here's the path, right? And so here's like in example 3 here we have -1 because the target is 8888, but since we have this kind of the dead end, which means so here the dead ends block all the path to this 88 to this target. That's why we have -1, right? And here are some constraints. Okay. So this one, every time you guys see this kind of minimum total number to reach from one state to another, right? Clearly, this problem we have a very clear start date and end date, right? Where the start date is the 4 zeros and end date is the target. And then it asks us to find the minimum movements, right, from the start date to the end date. And then this is a very clearly a BFS problem, right? And then so we also have this kind of dead ends, which means that those are the conditions we need to use whenever we try to explore the next path, right? Basically, if the next code or if the next value is inside the dead end, then we cannot go that route, right? Cool. So since we know it's a BFS problem, we can simply just start coding the BFS template, right? And so the start date is like a queue, right? So for me, I use the queue to do the BFS algorithm here, and then we have answer equals to 0, and we have a scene equals to set, right? And then scene dot add 0 0 4 zeros, right? And then we have a while loop, right? While q equals to this. So the BFS template, at least for me, I always use this kind of for loop. Or you can also store the step along with this value inside the queue, so that you don't have to maintain this one. But for me, I personally prefer using this for loop here. So we have a current, right? Current is going to be a queue dot pop left, right? And then here we're adding that, and then here we set answer +1, and then in the end return -1. It's always a good habit, to write the skeleton first. Later on we can fill in the logic when we try to for exploring to the next scenario, next of for loops, right? Because if you start implementing this one here along the way, you may forget about this answer plus one and even this one, even because right now you are thinking about this template and your mind is clear enough to not to make any mistake, But while you're implementing this kind of logic, and you have to you'll be start thinking about, okay, so how can I convert this string to integer and the integer back to string, something like this, right? If you start doing that, you may forget about this kind of answers, and then also this return stuff. You may also kind of like, oh, I may return answer in the end, but instead you should return -1, right? And right now it's also like good time to check any corner case, right? So what is the corner case? We haven't checked yet. Is this one? Is example 4 here, where the starting state, there's 4 zeros, is part of the dead end, which means that the if that's the case, we can simply return -1. Okay, but someone said, okay, what if the target is also 0, 0, 0, 0, right? And then that will be the answer. But here the constraints already tells us, the target will not be in the list of dead ends, right? So which means that this is like a corner case we need to handle here separately, because as you guys can see, we're assuming that the 0, 0, 0, 0 is not, we can move from here, right? So which means since we'll be using this dead end regardless, I'm going to convert this dead end into a dead set, right? So that we can use O1 time to compare. Okay, so basically if the 0 is in the dead set, right, then we simply return -1. All right, so once we have written this skeleton, we can start implementing the BFS, the logic, right? Where's the so current, if the current equals to target, right, then we return the answer. Okay. Otherwise, we try to find the next path, right? So since based on the description, we can move, we can turn any digits either forward or backward. So which means the first loop is going to be the range of 4, right? Since we have 4 digits in total, and for each digit we can either moving forward or backwards. Okay, so I'm just using a new one here. So to move forward we have this, right? New digits 1. Okay, it's going to be the what? Going to be the current I, right? The current I plus 1. But first we have to convert it into an integer so that we can do a +1, right? And then we do a modular by 10, right? Because for 9 we want 0, right? And then we have a new code, right? So the new code will be current.I, right, plus the string of the new digit 1, right, plus current of I plus 1, right? So this is the new code. New code 1 basically. And if the new code 1, right, not in scene, and new code 1 not in the dead set, right, then we add it to the queue. then scene dot add new code 1. Okay, right. So that's moving forward, and there's like another one. I can pretty much copy everything here. New code 2, right? I know this code is a little bit duplicated. So for turning backwards, we should do a -1, right? So that's going to be the logic. But if it's from zero, if you do a -1, it will become -1 divided by 10, by modular by 10 to 10, modular 10. So in all the other languages, this one will give you a -1. So which means we should do a 10. We do a +10 and then do a -1, right? But the funny thing is that in Python, this one will give you 9 instead of -1. I think that's the difference between the Python and other languages, because in Python, if you do a modular, it will always give you the value that have the same sign with this modular with it. But anyway, so if you're writing in C, C++, or Java, you need to do a +10 here. Cool. And I believe that's it, right? So we have 2 scenarios here, right? Either turn forward or turn backward. Okay, so let's try to run the code here. Yeah. Okay, accept it, right? Cool. So it passed, right? I mean, it's just a classic BFS solution. So for the time complexity for the BFS, for the while loop here, right? We have, so the total state we have here is what? We have 4 to the power of 10, right? Because we have 4 digits, each digit has like 10 possible state. So in total, we have this kind of state, right? 4 to the power of 10. And for each state, we have, so we have a for loop here, right? So we have 4, and then inside here, we need to do oh, sorry, my mistake. So here, the first one should be 10 to the power of 4, right? Because we total we have from 0 to 9999, right? Codes. That's why we have 10 to the power of 4, right? And then here for each of the code here, we have so we have a 4 here, right? And then to loop through each state, each digit, and for each digit we need to do some concatenation here, right? So that's why we have 4 to the power of 2, right? Because we have 4 and 4 here. And yeah, that's it, right? I mean, so that's the time complexity. Oh, and plus this one in at the beginning. So basically, this is the what? This is the, so we have what, 500, right? 500 times 4, right? That's 500 times 4 to put everything into the data set. Yeah, so that's the time complexity here, right? Yeah, and space complexity. We have this kind of data set, right? So this is the one of the space we need to use, which is the 500 times 4. And for the others, we have this Q, right? Or the scene set. So here we have, yeah, so this one is, the space complexity will be dominated by the 10 to the power of 4 times 4, right? So this one is gone. Yeah, so that's the space complexity. Yeah, I think that's it, right? For this problem, it's very just a very classic BFS problem. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.